Hi everyone, and welcome to math class for today. So yesterday we discussed rational and irrational numbers. So if you didn't finish the questions from yesterday, please pause the video and at least do number 3, 4, and 5. Okay, those are really important questions that you need to be able to do. And I know I gave you a lot of questions yesterday, so just please try to do those 3 questions. So again, that's number 3, 4, and 5 from yesterday, irrational numbers, okay? So today is 4.3, and that's mixed and entire radicals. So we're just going to do the first part with mixed radicals today. Okay, so here's a chart about perfect numbers. So we're going to learn about perfect squares, perfect cubes, and perfect fourths, and so on. There's many more, but these are the ones we're going to focus on. So what you do is you take the x value, so here's our x column, and you go in rows, right? So you're going to do x squared. So this is 2x. I'm going to try to write today, so I'm sorry if it's really messy. I'm with a mouse. So 2 squared is 4. Okay? This box is annoying. Sorry. All right, so we're going to have to live with it. So I want you to take a second and use your calculator and try to fill in as many of these as you can. Okay? So the square button and the cube button on your calculator is going to be pretty easy, but the fourth, you might not have that button. So I know on my calculator, I have a little upside down arrow. So all I do is would put 2, that little arrow, and then press 4 and then equals. But I know some people have a button that is y to the power of x. So you would put 2, you press that y to the x button, and then you put 4. Okay, so just play around and see what button you can use to get fourth. So I'm going to fill out the 4 row, okay? So 4 squared, all you need to put is the answer, okay? So all you need to put in this row is 16, okay? And then 4 to the power of 3, so 4 cubed is 64. And then 4 to the power of 4 is 256. Oh, lordy. Okay, so take a second, try to fill this out, make a chart in your notes, okay? And see how many you can get, because the next slide does tell you the answers, okay? So this is just to check your work, or if you were too lazy to do that work, here are the answers. And just know that you don't have to memorize this, but you will remember some of them because of repetition. Like an easy one is 2 to the power of 3, or 2 cubed is 8, right? Because you can find out all of these answers on your calculator, okay? So we often use perfect numbers in radicals. And I'm not sure if you've seen these before, but if not, it consists of a root symbol, an index, and a radicand. So the index is the number right in front of the root symbol, right? Because this is the root symbol. So n represents an index. So usually it's a 2, 3, or 4. If it is a square root, it doesn't often have a 2 there, okay? It's usually left blank. And then the radicand is this, okay? Is the letter or usually a number underneath the root symbol, okay? So this is what we're going to work on today, is the multiplication property of radicals. And this is a little troubling, so just take a break, keep rewinding the video if you need, but this is really important, okay? So we can look up here with this mess. I know it's annoying. Let's get rid of that. That was bad. So when there is a root symbol with an index of a number here, and you are multiplying, so see how there's no sign in between these letters? That's mean it's multiplying 2 different numbers. So this could be 3 and 2, okay? When you do that, it's equal to the square root, or the root of a. So if this was 3, this would be the square root of 3 times the square root of b, which let's say is 2. Okay, so it means it's the exact same thing. So this is where n is a natural number. We talked about that yesterday. And a and b are real numbers. So here's just an example. So we know so we're looking at the cubed root of 24. So inside that root is 8 times 3. Okay, and we split it up by saying that is equivalent to the cubed root of 8 times the cube root of 3. Do you see that, how it's this 8 split times the 3 split? Okay, and same thing with this, right? We have the square root of 5x, and that's equal square root of the 5 times the square root of the x. Okay, so just as with fractions, equivalent expressions for a radical have the same value, right? So all that means is that this is the exact same. The square root of 16 times 9 is the same as the square root of 16 times the square root of 9, because if you're just to solve the left side of this equation, so right here, right, that is 16 times 9 is 144, so the square root of 144 is 12. And then on the right side over here, we know that the square root of 16 times the square root of 9, well, these are perfect numbers. So the square root of 16 is 4, and the square root of 9 is 3. So 4 times 3 is 12, and they are equivalent. Okay, so that's all that's saying. So this is what we're going to use, or how we're going to use that information. We need to simplify radicals. So we find two factors of the radicand. So factors are numbers that we can divide the number by. So if it's 12, if the radicand is 12, we can say 6 and 2. But one has to be the largest possible perfect square, perfect cube, or perfect fourth, right? So you use a perfect square if the index is 2, you use a perfect cube if the index is 3, and so forth, okay? So these are just the numbers from the chart. And then you take that root of the perfect square or whatnot and multiply by the radical factor remaining. So the thing that you can't take the perfect square of, okay? Oh, so we're just going to do this. I'm just going to cover one of these up. So sorry for 1 second. Okay. And one more. See if it'll let me do it. I'm just going to walk through these two. Okay. So the square root of 80. So we're doing square roots, so the index is 2, so we need to find a perfect square, the biggest perfect square of 80. So that is 16. So 16 times 5 is 80. So 16 is my perfect square, so we're going to separate these, right? 16 times the square root of 5, because 5 does not have a perfect square root. So the square root of 16 is 4, and then we leave the radical of 5. Do you understand? So then over with the square root of 75, we take the biggest perfect square, which is 25 times 3. So then we separate them, and the square root of 25 is 5. So 5 with the remainder of square root of 3. So look at C here. This is where it gets a little confusing when we add in variables, okay? So with variables and exponents, we add the exponents, okay? So like 2 times 2, like 2 plus 2, if it's x squared times x squared, that's x to the power of 4. Okay, so what we're trying to do is make sure it's a multiple of 2. So that's what we're going to take out. So like the lowest number if it's an odd number, or the next number. So 54x cubed. So it's still square root. So what we're going to do is just look at the number first, okay? So 54. So the largest perfect square is 9. And then we can look here and say, oh, okay, so we have x cubed. So x cubed, the next even number is x squared. So we write that. And then 9 times 6 is 54. So x, or 6x. So then we split those two up. So we have 3x and then the remainder, because we took the square root of this, right? So the square root of the x squared is x. So then 3x to the square root 6x. Okay, so let's do this one together and hopefully we can see. So we have the square root of 200x5. So we need to find the biggest perfect square of 200x5. So that is 100. Oh, goodness. And then the next even number of that exponent is 4. And then what do we have to multiply this by to get 200x5? It's 2x. Right? So now we split this up. So 100x4. Oh, I apologize. This is horrendous. Times the square root of 2x. Right? So now we take the square root of 100x4, which is 10x squared times 2x. Okay, and then just take a second over here. It's the exact same thing with two variables. Okay, so all it's doing is breaking up 108 into 36 and 3, and then x squared, that is an even number, so we can leave that. And then the next lowest number for y to the power of 7 is y to the 6. Then we leave what we can't take the perfect square of. So then 6x y to the power of 3 times the square root of 3y. Okay, so take a second on this and work through them and look at these answers and see how I got them. Okay, so now what I want you to do today is to do some problems from this worksheet. And by referring back to those example questions, hopefully they're not too challenging. So I know I gave you a lot to do yesterday, so I'm just going to make you do 6 questions. So see how I have that here? Let's see, maybe I'll get yellow and we can just highlight a little bit. So only do 6 of these questions, okay? So I say pick 2 questions in each bundle. Bundles meaning where the commas are. Okay, so for example, do number 1 and 3 out of this bundle. Maybe do 10 and 11 out of this bundle. Maybe do 18 and 12 or in 20. Okay, so whatever ones you want to do, but I need you to do 6. Okay, and then you're going to do this worksheet, and I only want you to do 3 of these questions. I don't care which numbers. Maybe you do 25, 18, and 7. Okay, it doesn't matter, but I want you to do 3. If you do have lots of time, or maybe you do want to practice and you're unsure, please try to do more of these questions. You can do all of them, right? That would be lovely, but I do want to limit it to you, okay? I'm also going to post the answer key of these worksheets so you know what you're doing. And if you're really struggling, or if you just have a little bit of an issue, or you just want to clarify something, please come to the Google Meet, okay, today or on Monday, and we can go through some of these questions, okay, or email me and I'll try to see and I'll be prepared to help you out, okay? So good luck, try your best, and have a great day.